Bora. One more. Mais uma live. E vambora. Vamos continuar. Hoje a meta é 1 hora de estudo. Terminar essa aula aqui e Scratch. Oh, agora eu fiquei brancão. Vambora. Eu vou desligar o mic. Tá? Vou desligar o mic. Porque eu quero ficar sem fone. Eu tô... ficando meio foda. Então vambora. Hoje a meta dessa semana é estudar 3 vezes, tá? Então, estudar 3 vezes aqui do Odin, né? Então vambora. Então eu vou tirar o fone, vou deixar aqui, mas é isso. Valeu, falou, fui. Ficar sem fone aqui, vou focar nos estudos.
David.
All right, little ransom-like instead. All right, so that's just some additional puzzle pieces, but really just the same idea. But I like that we've introduced some sound. So let's do this. Let me go ahead and throw away a lot of those puzzle pieces, leave ourselves with just the when green flag clicked, and play around with some other building blocks that we've seen already thus far. Let me go ahead, for instance, under sound, and let's make the cow actually meow. So it turns out Scratch, being a cat by default, comes with some sounds by default, like meowing. So if we go ahead and click the green flag after programming this program, let's hear what he sounds like now. Okay, kind of cute. And if you want it Scratch to meow twice, you can just play the game again. And a third time. All right, but that's going to get a little tedious, as cute as it is. So I can solve that. Let's just grab 3 of the puzzle pieces and just drag them together and let them connect. And now click the green flag. All right, it gets less cute quickly, but maybe we can slow it down so that the cat doesn't sound so hungry maybe. Let me go under... let's see, under control, let's grab one of those wait 1 second and maybe plop a couple of these in the middle here. That might help things. And now click the green flag. OK, still a little hungry, but let's see if we change it to 2, and then I change it to 2 down here in both places. Let's play it again. OK, cuter, maybe. But now I'm venturing into badly programmed territory. This is correct. If my goal is to get the cat to meow 3 times, pausing in between, 3 times, pausing in between, what is bad about this code, even if you've never programmed before, though? Yeah, in the middle? Yeah, I literally had to repeat myself 3 times, essentially copy pasting. And frankly, I could have been really lazy and I could right click or control click and I could have chosen duplicate. But generally, when you copy paste code or when you duplicate puzzle pieces, probably doing something wrong. Why? It's solving the problem correctly, but it's not well designed, even if for only because when I changed the number of seconds, now I had to change it in 2 places. So I had 1 initially, then I had to change it to 2. And if you just imagine in your mind's eye having not like 6 puzzle pieces, but 60 or 600 or 6,000, you're going to screw up eventually. If it's on you to remember to change something here and here and here and here, like you're going to mess up. It's better to keep things simple and ideally centralized by factoring out common functionality. And clearly, playing sound and waiting is something I'm doing at least twice, if not a 3rd time here as well. So how can we do this better? Well, remember this thing. loops. Maybe we can just do something a little more cyclically. So I tell the computer to do something once, but I tell it how many times to do that all together. So notice here, by coincidence, under control, I have a repeat block, which doesn't say loop, but that's certainly the right semantics. Let me go ahead and drag the repeat block in, and I'll change the 10 to 3. Just for consistency here. I'm going to go back to sound. I'm going to go ahead and play sound meow until done, just as before. And just so it's not meow going too fast, under control, I'm going to grab a wait 1 second and keep it inside the loop. And notice that the loop here is sort of hugging these puzzle pieces by growing to fill however many pieces I actually cram in there. So now if I click play, the effect is going to be the same, but it's arguably not only correct, but also well designed. Because now if I want to change the weight, change it in one place. If I want to change the total number of times, change it in one place. So I've modularized the code and made it better designed in this case. But now this is silly because even though I want the cat to meow, it feels like any program in which I want this cat to meow, I have to make these same puzzle pieces and connect them together. Wouldn't it be nice to invent the notion of meowing once and then actually have a puzzle piece called meow, so when I want the cat to meow, it will just meow? Well, I can do that too. Let me scroll down to my blocks here in pink. I'm going to click make a block, and I'm going to literally make a new puzzle piece that MIT didn't think of called meow. And I'm going to go ahead and click OK. Now I have in my code area here a define block, which literally means define meow as follows. So how am I going to do this? Well, I'm going to propose that meowing just means to play the sound meow until done and then wait 1 second. And notice now I have nothing inside my actual program which begins when I click the green flag. But notice at top left, because I made a block called meow, I now have access to one that I can drag and drop. So now I can drag meow into this loop. And per my comment about abstracting the lower level implementation details away, I'm going to sort of unnecessarily, dramatically just move that out of the way. It still exists. I didn't delete it. But now out of sight, out of mind. Now, if you agree with me that meow means for the cat to make a sound, we've abstracted away what it means mechanically for the cat to say that sound. And so we now have our own puzzle piece that I can just now use forever because I invented the meow block already. Now, I can do one better than this. It would be nice if I could just tell the meow block how many times I want it to meow, because then I don't need to waste time using loops either myself. So let me do this. Let me zoom out. And let me go back to my define block. Let me right click or control click and just edit it. Or I could delete it and start over, but I'll just edit it. And specifically, let me say, you know what? Let's add an input, otherwise known as an argument. to this meow block, and we'll call it maybe n for the number of times I want it to meow. And just to be super clear, I'm going to add a label, which has no functional impact, but it just helps me remember what this does. So I'm going to say meow n times, so that when I see the puzzle piece, I know what the n actually represents. If I now click OK, my puzzle piece looks a little different at top left. Now it has the white oval into which I can type or drag input. Notice down here in the define block, I now see that same input called n. So what I can do now is this. Let me go under Control, drag the repeat block here. And I have to do a little switcheroo. Let me disconnect this, plug it inside of the repeat block, reconnect all of this. And I don't want 10. And heck, I don't even want 3 down here anymore. I can drag this input, because it's the right shape, and now declare that meowing n times means to repeat the following n times. Place sound meow until done, wait 1 second, and keep doing that n total times. If I now
hot dogs, beer, hot dogs.
Now zoom out and scroll up. Notice that my usage of this puzzle piece has changed such that I don't actually need the repeat block anymore. I can disconnect this. And heck, I can actually right-click and control-click and delete it. Just use this under the green flag, change this to a 3, and now I have the essence of this meowing program. The implementation details are out of sight, out of mind. Once they're correct, I don't need to worry about them again. And this is exactly how Scratch itself works. I have no idea how MIT implemented the wait block or the repeat block. Heck, there's a forever block, and there's a few others, but I don't need to know or care because they've implemented those building blocks that I can then implement myself. I don't necessarily know how to build a whole chatbot, but on top of OpenAI's API, this web-based service, I can implement my own chatbot because they've done the heavy lift of actually implementing that for me. Well, let's do just a few more examples here. Let's bring the cat all the more to life. Let me throw away the meowing. Let me open up under when green flag clicked. How about that forever block that we just glimpsed? Let me go ahead and now add to the mix what we called earlier conditionals, which allow us to ask questions and decide whether or not we should do something. So under this, let me go ahead and, under forever, say if the following is true. Well, what Boolean expression do I want to ask? Well, let's implement, how about this program, and we'll figure out if it works. Under sensing, I'm going to grab this a very angled puzzle piece called touching mouse pointer, that is the cursor. And only if that question has a yes answer do I want to play the sound meow until done. So let me zoom in here. And in English, what is this going to implement, really? Just describe what this program does less arcanely as the code itself. Yeah? Yeah, if you move the mouse over the cat, it will make noise. So it's kind of like implementing petting a cat, if you will. So let me zoom out, click the green flag, and notice nothing's happening yet. But notice my puzzle pieces are highlighted in yellow because it is, in fact, still running because it's doing something forever. And it's constantly checking if I'm touching the mouse pointer. And if so, it's like I just pet the cat. Now it stopped until I move the cursor again. Now it stopped. If I leave it there, it's going to keep meowing because it's going to be stuck in this loop forever. But it's correct insofar as I'm petting the cat. Let me do this, though. Let me make a mistake this time. Let me forget about the forever and just do this. And you might think this is correct. Let me click the green flag. Now let me pet the cat. And like nothing's actually working here. Why, though, logically? Yeah. Yeah, the program's so darn fast, it already ran through the sequence. And at the moment in time when I clicked the green flag, no, I was not touching the mouse pointer. And so it was too late by the time I actually moved the cursor there. But by using the forever block, which I did correctly the first time, this ensures that Scratch is constantly checking the answer to that question. So if and when I do pet the cat, it will actually detect as much. All right, how about a few final examples before you're on your way building some of your own first programs with these buildings. blocks. Let me go ahead and open up a program that I wrote in advance, in fact, about 20 years ago, whereby, let me pull this up, whereby we have, in this example, a program I wrote called Oscar Time. And this was the result of our first assignment in this class, whereby when MIT was implementing Scratch for the very first time, we needed to implement our very own Scratch program as well. I'm going to go ahead and full screen it here. The goal is to drag as much falling trash as you can to Oscar's trash can before his song ends, for which one volunteer would be handy here. OK, I saw your hand go up quickly. In blue, yeah, come on up. All right, so you're playing for a stress ball here, if we will. At some point, I'm going to talk over what you're actually playing just so that we can point out what it is we're trying to glean from this program. And I'll stipulate this probably took me like 8, 12 hours. And as you'll soon see, the song starts to drive you nuts after a while because I was trying to synchronize everything in the game to a childhood song with which you might be familiar. Let me go ahead and say hello if you'd like to introduce yourself.
Oh, hello. So I'm Han, and I'm a first-year student. I'm pretty excited for this class.
All right, welcome. Well, here is Oscar Time. If you want to go ahead and take control of the keyboard, all you'll need to do is drag and drop trash that falls from the sky into the trash can.
I think a lot of it honestly comes from a place of insecurity. Like, I really don't want to be the one on stage in front of a bored audience. Like, no one.
Oh, I love trash. Anything dirty or dingy.
Very nice. Your score is 1.
Anything ragged or rotten or rusty.
Nice. Score is 2.
Yes, I love trash.
All right,
If
good.
you really
3.
want to see something trashy, look at
And
this.
let's see what happens.
I have here a sneaker that's
You'll see a sneaker was perfectly timed. Thank you very much with the song after figuring out exactly how many seconds it had to wait. Now Han can drag not only the piece of trash, but the shoe as well.
I love it because it's trash.
And it's around this point in the game where the novelty starts to wear off, because there's like 3 more minutes of this game where more and more stuff starts to fall from the sky. So as Han, as you continue to play, I'm going to cut over here. You keep playing. Let's consider how I implemented this, whereby we'll start at the beginning. The very first thing I did when implementing Oscar Time, honestly, was the easy part. Like, I found a lamppost that looked a little something like this, and I made the so-called costume for the whole stage. And that was it. The game didn't do anything. You couldn't play anything. You clicked the green flag, nothing happened. But then I figured out how to turn the Scratch cat, otherwise known more generally as a sprite, into a trash can instead. And so the trash can, meanwhile, is clearly animated because I realized that, oh, I can give sprites, like the cat, different costumes. So I can make the cat not only look like a trash can, but if I want its lid to go up, well, that's just another costume. And if I want to see Oscar popping out, that's just a third costume. And so I made my own simplistic animation, and you can kind of see it. It's very jittery, step by step, by creating the illusion of animation by really just having a few different images or costumes on Oscar. Now, I hope you appreciate how much effort went involved into timing each of these pieces of trash with the specific mention of that type of piece of trash in the music. OK, 20 years later, still clinging. So you're doing amazing, by the way. How do we get the trash to fall in the first place? Well, at the very beginning of the game, the trash just started falling from some random location. What does it mean for trash to fall from the sky? Big climax here. No, you got a lot of trash on the ground. You should pick up. There we go. And your final score is a big round of applause, if we could, for Han. Okay. Thank you. So just to be clear, now let's decompose this fairly involved program that took me a lot of hours to make into its component parts. So this is just a sprite, and I figured out eventually how to change its costume to simulate some kind of animation. And I also realized that, oh, I don't need to just have one sprite or one cat or trash can. You can create a second sprite, a third sprite, and many more. So I just told the sprite to go to a random location at y equals 180 and x equals something. I think I restricted x to be in this region, which is why the trash never falls from over here. I just did a little bit of math based on that Cartesian plane that we saw a slide of earlier. And then I probably had a loop that told the trash to move a pixel, move a pixel, move a pixel, down, 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 until it eventually hits the bottom and therefore just stops. So we can actually see this step by step. And this is representative of how, even for something like your first problem said in CS50 and with Scratch specifically, you might build some of the same. So I'm going to go back into CS50 Studio for today, which is linked on the course's website, which has a few different versions of this and other programs called Oscar 0 through Oscar 4, where 0 is the simplest. And truly, I meant it when I look inside this program to see my code. Like, this was it. There was no code because all I did was put the sprite on the screen and change it from a cat to a trash can. And I added a costume for the stage, so to speak, so that the lamppost would be fixated there. If I then go to the next version of code, version 1, so to speak, then I had code that did this. Now notice there's a few things going on here. At bottom left, you'll see, of course, the trash can, and then at top right, the trash. Here are the corresponding sprites down here. So when Oscar is clicked on here, the trash can, you see the code I wrote, the puzzle pieces I dragged for Oscar. And in a moment, when we click on trash, you'll see the code I wrote, or the puzzle pieces I wrote, dragged and dropped for the trash piece specifically. So what does Oscar do? Well, I first switch his costume to Oscar 1, which I assume is this, the closed trash can. Then forever, Oscar does the following. If Oscar's touching the mouse pointer, then change the costume to Oscar 2. Otherwise, that is, if not touching the mouse pointer, change the costume to Oscar 1. Well, what's the implication? Anytime I move the cursor over the trash can, the lid just pops up, which was exactly the animation I wanted to achieve. Meanwhile, if we do this and click the green flag, you can see that in action even for this simple version. If I move the cursor over Oscar, we have the beginnings of a game, even though there's no score, there's no music or anything else, but I've solved one of my problems. Meanwhile, if I click on the trash piece here, and then you'll see no code has been written for it yet. So we move on to Oscar version 2 and see inside it. In Oscar version 2, when I click on trash, now there's some juicy stuff happening here. And in fact, this trash sprite has 2 programs or scripts associated with it, and that's fine. Each of them starts with when green flag clicked, which means the piece of trash will do 2 things at once, essentially in parallel. The first thing it will do is we'll set drag mode to draggable, and that's just a Scratch thing that lets you actually move the sprites by clicking on them, making them draggable. Then it goes to a random X location between 0 and 240. So yeah, that must be what I did, from the middle all the way to the right. And I set Y always to 180, which is why the trash always comes from the sky, from the very top. Then I said forever, change your Y by -1. And here's where it's useful to know what 180 is, 240 is, and so forth. Because if I want the trash to go down, so to speak, that's changing its Y by a pixel, by a pixel, by a pixel. And thankfully, MIT implemented it such that if the trash tries to go off the screen, it will just stop automatically, even if it's inside of a forever block, lest you lose control over the sprites altogether. But in parallel, what's happening is this. Also, when the green flag is clicked, the trash piece is doing this too. Forever, if touching Oscar, what's it doing in blue here? Sort of teleporting away. Now, to your eye, hopefully, it looks like it's going into the trash can. But what does that mean to go into the trash can? Well, I just put it back into the sky as though a new piece of trash is falling. So even though you saw one piece of trash, 2, 3, 4, and so forth, it's the same sprite, just acting that out again and again. So here, if I click play on this program, you'll see that it starts falling 1 pixel at a time. Because it's draggable, I can sort of pull it away and move it over to the trash can like that. And as soon as I do, it seems to go in, but really it just teleported to a different X location, still at Y equals 180. Again, it's not much of a game yet. There's no score, there's no music or anything. But let's go to Oscar 3 now. And in Oscar 3, if we scroll over to the trash, even more is happening here insofar as I realized, you know what, there was kind of an inefficiency before. Previously, I had these 2 programs, or scripts, synonym, whereby they both went to the top by going to 0 to 240 for X and then 180 for Y. And if you noticed, I used that here and I used that down here in both programs. Now, that too is kind of stupid because I literally copied and pasted the same code. So if I ever want to change that design, I have to change it in 2 places, and I already proposed that we frown upon that. So what did I do in this version? I just created my own block, and I decided to call my own function goToTop, What does it mean to go to the top? Pick a random x between those values and fixate on y equals 180 initially. Now, in both of those programs, which are otherwise identical, I just say what I mean. Go to top, go to top. And if I really wanted to, I could drag this out of the way and never think about it again, because now that functionality exists. So correct, but arguably better designed. I've now factored out commonality so as to use and reuse my code as well. So let's go up to Oscar version 4 now. And in Oscar time version 4, the trash can does a little something more, whereby what have I added to this mix, even though we haven't dragged this puzzle piece together before? Yeah, what's new? Yeah, so it turns out on the left here, there's a variables category, which goes beyond the answer variable that we just automatically get from the ask block. You can create your own variables, x, y, z, but in programming, it's best to name things not silly, simple words like x, y, and z, but full-fledged words that say what they are, like score. So I'm setting a score variable to 0. And then anytime the trash is touching Oscar before it teleports away to the top, I change the score by 1. That is, increment the score by 1. And what Scratch does automatically for me is it puts a little billboard up here showing me the current score. So if I now play this game once more, the score is going to start at 0. But if I drag this trash over here and even let it fall in, as soon as it touches, the score goes to 1. And now if I click and drag again, the score is going to, as soon as it touches Oscar, going to go to 2. And so forth. And you saw in the final flourish with Han playing that once you add the sound and other pieces of trash, which are just really other sprites, and I just had wait like a minute, wait 2 minutes, so that the trumpet would fall at the right time, I've broken down a fairly involved program into these basic building blocks. And when you too write your own program, that's exactly how you should approach it. Even if you have these grand aspirations to do this or that, start by the simple problems and figure out what bites can I bite off in order to make progress, baby steps, if you will, to the final solution. Well, let's look at one other set of examples before we have one final volunteer to come up. And as you'll soon see, it's tradition in CS50 to end the first class with cake. So in a moment, cake will be served out in the transept. And please feel free to come up and say hi and ask questions if you'd like to. Let me go ahead and open up, though, a series of building blocks here via which we can make so-called Ivy's hardest game, which is one implemented by one of your predecessors, a former classmate from CS50. So here we have a whole bunch of puzzle pieces written by your classmates. But, and let me go ahead and zoom in on this screen, you'll see that this Harvard crest is my sprite. So it's not a cat, it's not a trash can, it's a Harvard crest. And it exists in a very simple two-dimensional world with two walls next to it. If I click on the green flag, notice that with my hands here, I can go up, I can go down, I can go left, and I can go right. But if I try going too far right, I get stuck on the wall. If I go too far left, I get stuck on the wall. Well, it's sort of the beginning of any animation or game. But how do I do this? Well, let me go up here and propose that the first thing the Harvard sprite is doing is it's going to the middle, 0, 0. And it's then forever listening for the keyboard and feeling for walls. Now, those are functions I implemented myself to kind of describe what I wanted the program to do. And let's do the shorter one first. What does it mean to feel for the walls? Just to ask the question, if you're touching the left wall, change your x by 1. If you're touching the right wall, change your x by -1. Why have I defined touching walls in this weirdly mathematical way? Yeah. Sure, yeah.
Hey, folks. Hey, folks. And some, like, if you've really tried to come up with examples on your own, ask questions, answer them, then you'll probably be able to tell, like, hey, folks.
Houston, we have a problem.
I created a bit of a problem last week by offering to
Exactly, because if I've gone so far right that I'm touching the right wall, well, I'm already kind of on top of the wall a little bit, so I effectively want the sprite to bounce off of it. And the easiest way to do that is just to say, back up 1 pixel, as though you can't go any further, and same for the left wall. Meanwhile, let me scroll over to the second script or program that's running in parallel. It's a little longer, but it's not more complicated. What does it mean to listen for keyboard? Well, just check. If the key up arrow is pressed, change y by 1. ergo go up. Else if the key down arrow is pressed, then change y by -1. Key right arrow is pressed, change x by 1, and so forth. So again, this is where the math and the numbers are useful, because it gives you a world in which to live, up, down, left, right, deconstructed into some simple arithmetic values. All right, so the net result is that we have a crest living in this world. Well, let's add a bit of competition here. And in the second version of this game, let me go ahead and full screen it again, click play, and now we'll see sort of an enemy bouncing back and forth autonomously. So there's no one playing except me. I'm controlling Harvard. Yale is bouncing on its own. And nothing bad's going to happen if it hits me, but it does seem to be autonomous. So how is this working? Well, if it's doing this forever, there's probably a forever loop involved. So let's see inside here. Let's click not on Harvard, but on the Yale sprite. And sure enough, if we focus on this for a moment, we'll see that the first thing Yale does is go to 0, 0. It points in direction 90 degrees, which just gives you a sense of whether you're facing left or right or wherever. And then it forever does the following. If it's touching the left wall or touching the right wall, I was a little clever this time, if I may. I just kind of turn around 180 degrees, which effectively bounces me back in the opposite direction. Otherwise, I go ahead and no matter what, just move one step. And this is why Yale is always moving back and forth. So a quick question. If I wanted to speed up Yale and make this beginning of a game harder, what would I do? Yeah. Yeah, so let's have it move like 10 steps at a time. Right? This looks like a much harder game, if you will, like level 10 now, because it's just moving so much faster. All right, well, let's try a third version of this that adds another ingredient. Let me full screen this and click play. And now you'll see the even smarter MIT homing in on me by following my actual movements. So this is sort of like boss level material now. And it's just going to follow me. So how is this working? Well, it's kind of a common game paradigm, but what does this mean? Well, let's see inside here. Let's click on MIT sprite. It's pretty darn easy. Go to some random position, just to make it a little interesting, lest MIT always start in the center, and then forever point towards the Harvard logo outline, which is the name the former student gave to the costume that the sprite is wearing that looks like a Harvard crest, and then move one step. So a corollary of the previous question, how do we make the game harder and MIT even faster? Well, we can change this to be like 10 steps. And now you'll see MIT is a little twitchy because this is kind of a visual bug. Let me make it full screen. Why is this visual glitch happening? It's literally doing what I told it to do. It just looks stupid. Yeah. Say it again? Yeah, it's moving so fast that it's sort of going 10 pixels this way, but then it kind of overshot me, so then it's doubling back to follow me again, and it's doubling back this way. And because these are such big footsteps, if you will, it just has this visual effect of twitching back and forth. So we might have to throttle that back a bit and make it 5 or 2 or 3 instead of 10, because that's clearly not desirable gaming behavior here. All right, well, let's go ahead and do this. Let's put them all together, just as your former classmate did when submitting this actual homework. The game will conclude, hopefully, in an amazing climax where you've won the game. So we need someone, ideally, with really good hand-eye coordination to play this final game here. Yeah? Your hand went up first, I think. OK, come on up. Big round of applause, because there's a lot of pressure to end. All right. So if you win the game, cake will be served. If you don't win the game, there will be no cake. OK, but introduce yourself in the meantime.
Hi, I'm Jenny Pan, freshman at Hollis, and I'm actually a CS major, or concentration.
Nice to meet you. Head to the keyboard here. This now is the combination of all of those building blocks and even more, aka IB's hardest game. You will be in control, just as I would, of the Harvard crest, and the goal is to make it to the exit, which is this gentleman on the right here, and you'll see there's multiple levels, where each level gets a little harder. All right, here we go.
You can't touch this. You can't touch this.
Very good.
You can't touch this.
Nicely done.
You can't touch this.
So the loop has been added for Yale. Good. 2 Yales now. All right. 3 Yales now. Nice. Here comes MIT. Very good. Yeah. 2 MITs. Nice. Yes. Yes, yes. Now Princeton. Another Princeton. Second to last level. Yes, last level. So close, keep going, keep going. Yes! Congratulations. All right, this is CS50. Cake is now served.
Bom, vamos lá. Como que eu aprendi a programar? Eu comecei com um CS50, para quem não conhece, o seu trabalho com gerenciamento manual de memória, então é algo um pouco mais complexo, mas que vai te dar um entendimento muito bom sobre como os computadores funcionam, como realmente funciona o que você está fazendo no Python por baixo dos panos, né? Se você só programa e já começa programando em Python, você vai ter um pouco de dificuldade de entender o que está realmente acontecendo, porque o Python ele faz uma abstração, ele basicamente esconde muita coisa de você. Por isso que, pelo menos... Bom,
Terminamos a primeira aula. Agora, vamos tentar, mano. Vamos tentar fazer esse aqui que eu quero fazer, né? O jogo que eu quero fazer, basicamente, é fazer. O que eu quero fazer agora é fazer a tela inicial. O mesmo jogo que eu quero fazer é tipo um Before Sunrise de texto, tá ligado? Mas primeiro eu vou anotar aqui as coisas que eu tenho que fazer. O meu vai ser uma história interativa, né? É isso, rapaziada. Eu planejei um pouco aqui o que ele vai fazer. Ser um jogo interativo, tipo, Before Sunrise. E a gente vai ter que, tipo, tentar convencer a moça a sair do trem pra Viena, que é a história inicial do filme, que é o que o personagem faz, né? Então acho interessante a gente conseguir fazer isso. O Scratch tá aqui, eu tô com uma conta. A gente terminou. Então é isso, rapaziada. Falou, fui. Amanhã eu vou dirigir e quarta a gente começa.